With the name of Allah Almighty, dear students and other viewers, may peace be upon all of you. I am Dr. Engineer Majid Amin, subject specialist mathematics from Peshawar, Pakistan. And I am here to discuss a new topic of this chapter, matrices, 9th class mathematics. Topic is properties of inverse and transpose of a matrix. Properties are written in front of you. We will discuss them turn by turn. In the last lecture, I discussed in detail about the inverse of matrix. I hope there is no confusion in that topic. This is pronounced as A inverse. Still, if you have not watched that video, I would go through that topic briefly. For example, I am given this matrix. When I say find the inverse of this matrix, it automatically means that which matrix will be multiplied with this given matrix to get identity matrix. This matrix is called inverse of this matrix. We have to search for this matrix. And now to reach at that matrix, we go through some steps called determinant, adjoint, then formula. So I hope no confusion. Just a brief overview of that topic. Multiply these two 6, multiply these two minus 4. A determinant is equal to 10. Then there is a topic called adjoint, A adjoint. Places change, signs change. Right, students? Then A inverse is equal to 1 by A determinant into A adjoint. I hope it is very simple for you. A 2, 1 minus 4, 3. If you multiply, it's up to you. But this is A inverse. This is what? Inverse. Multiply 1 by 10 multiplied by 2 is 1 over 5. 1 over 10 minus 2 over 5. 3 divided by 10. This is A inverse. This is the matrix which we were searching for. Now, if you verify that property, 1 over 5, 1 upon 10, minus 2 upon 5, 3 upon 10. Okay. Multiply first row, first column, students, 3 by 5 plus 2 by 5, 3 by 10 minus 3 by 10. Multiplication of two matrices, 4 by 5 minus 4 by 5, 4 by 10 plus 6 by 10. Students, 3 by 10 minus 3 by 10 cancel. Here you get 0, 0. And this is 4, 5 will be LCM. 3 plus 2, 5 by 5 is 1. 10 is the LCM. 4 plus 6, 10 by 10 is equal to 1. It is the inverse, number 1. Okay, students. So first so this property is clear. I hope A multiplied by A inverse will be always equal to identity. And A multiplied by identity will be always equal to A identity matrix. Now, students, let's to try to verify this property because it is straightforward. For example, my sweet students, you come across this MCQ in your paper and he says find A inverse, find determinant of A inverse. Determinant of A inverse. So, my sweet students, there will be multiple options. For example, so there is a student who comes and he finds A inverse. First, he finds A determinant. Then the moment he writes A adjoint, it automatically means that he doesn't know the property or he is not interested in the property. There are two possibilities. Either he is not interested in the property or he is not interested in using this property. There are two possibilities, and most probably he has no knowledge of this property. So he goes and he all the way he determines A inverse. Then he says, okay, what will be A inverse determinant? Because A inverse is just a matrix like A. 1 by 5 minus 2 by 5. Students, multiply them. Multiply these two. Minus multiply these two. My sweet students, 3 divided by 50 plus 2 divided by 50, 50 LCM, 3 plus 2, 3 plus 2 is equal to 5 by 50 is equal to 1 by 10 is equal to 0 0.1. So simple, 0 0.1. Right, students? Okay, 1 by 10. There was no need of this procedure. I mean to calculate, to determine the determinant of A inverse. You don't need to determine A inverse. There is no need. You could just say that first you just find A determinant is equal to 10. Determinant of inverse will be equal to 1 upon A determinant. Just put the value. Means the determinant of inverse will be the reciprocal of A determinant. For example, A determinant is 4. A inverse determinant be 1 by 4, 0.25. It is very simple. So this property is also clear to you now. Okay. Then A inverse whole inverse. A inverse whole inverse. Students, I will just write here A inverse. I will directly write A inverse is equal to 1 over 5. I will need it later on. Minus 2 by 5. 3 divided by 10. This is A. This is A inverse. I wrote it down for my later on topics. Okay, students. Now, what does it mean? If you take the inverse of A inverse, you will again end up with that matrix A. Now, there are two possibilities. One possibility is, my students, that you have this matrix A inverse. So, you can calculate the inverse of A inverse because this formula simply means matrix inverse is equal to 1 over determinant of the matrix M into adjoint of that matrix M. So in the previous case, for that particular problem, this matrix was A, the M was A, and we said A inverse. Just hide it for your convenience. Here we will have determinant of that, A determinant into A adjoint. Now here A inverse whole inverse means this M is A inverse. What will be the inverse of A inverse? So by that formula, I will have A inverse determinant into A inverse adjoint. Yes, this is one possibility. You can prove this formula within 3-4 steps, but we will discuss it after that proper procedure. So here A inverse is equal to, this is M inverse 1 upon M determinant, M adjoint, M inverse 1 over M determinant. Its inverse 1 upon determinant of this into adjoint of this. Okay. So its determinant is 1 over 10, 1 upon 10. Now students, what will be A inverse adjoint? Places change. Our signs change. Right students, so A inverse whole inverse by that formula. Okay, put the values of A inverse determinant and adjoint. This is A inverse determinant is 1 over 10 into A inverse adjoint is 3 by 10. 1 by 10 minus 2 by 5 and 1 over 5. This 10 will go up. 3 by 10 students, 1 by 10 minus 2 by 5, 1 over 5. Now just multiply this 10 with all the elements. You will get 3, 1 minus 2, sorry, minus 4, multiply by 10, 2, and it is equal to A. You can see. Students, A inverse adjoint. Places change and signs change. Really sorry, students. Signs change. This will be plus. So here I will have minus 1 over 10 and this will be plus. This is minus, this is plus, this is minus, this is plus, and it is equal to A. I hope it is clear. This is one way. This is one way to prove this, that A inverse whole inverse is equal to A. The second possibility is, it was simple, but the second method is much simpler. My students, for example, you say that as we know that there is no confusion, A multiplied by A inverse is equal to identity. Right, students? What if I say multiply both sides by A, multiply both sides by A inverse, whole inverse from right? I have this equation, A multiplied by A inverse is equal to identity. I say multiply both sides by A inverse whole inverse. A inverse whole inverse. Now what is this? This is inverse of this. Whenever we have matrix multiplied by inverse of the matrix, the result will be identity. Here the matrix is A inverse. So we have A inverse multiplied by this is matrix, this is inverse of the matrix. Suppose this is M inverse. A inverse into A inverse inverse. So the product of matrix and its inverse will always give you identity. And identity multiplied by, identity into A inverse whole inverse. Now my students, whenever we have matrix multiplied by identity, result will be the matrix. Matrix multiplied by identity, result will be the matrix. Identity A inverse whole inverse. So clearly we see that A inverse whole inverse is equal to A. We proved this result without taking a particular matrix. I assume this is the most suitable way. Okay, students, now let's discuss this property. A B whole inverse is equal to B inverse A inverse. Students, I take a very simple matrix so that its determinant is for example, my students. Okay, no problem. It's okay. What is its determinant? Shabash. What is its determinant, students? 0 minus 2 is minus 2. Right? Take it minus so that we have plus 2 as determinant. And what is a B adjoint? Students, B adjoint places change and signs change. This is students B adjoint. Now by that formula, B inverse will be equal to 1 by B determinant into B adjoint. Multiply this with this to 0. Multiply this with this, we get 1 by 2. When you multiply, you get minus 1 and you get 1 by 2. This is your B inverse. I have these values. And what is this? AB whole inverse. Now let's try to find AB whole inverse. AB, first find AB. AB. To determine this, first you have to calculate A multiplied by B. Because we want to take inverse of AB. Inverse of AB matrix. So first I am going to determine AB. Students, these are two matrices AB, first row, first column, 3 minus 2, direct 1. Students, minus 3 minus 0. Students, second row, first column, 4 plus 4, and this will be minus 4 plus 0. AB is 1, minus 3, 8, minus 4. Now, students, you can find AB determinant minus 4 minus 24. It will be equal to minus 4 plus 24 is equal to 20. I think simple. Then you determine AB adjoint. Students, places change, AB adjoint. Places change and signs change. Finally, you will have to determine AB inverse. Inverse of matrix AB. 1 upon AB determinant into AB adjoint. Students put the values. A, B determinant in this case is 20. And A, B adjoint is -4, 3, -8, 1. You can multiply. It will give you -1/5. 3 divided by 20, -4 by -2/5. 8 by 20 is -2 by 5, and 1 upon 20. This is your result, AB whole inverse. Now you find B inverse A inverse. B inverse is which matrix? This matrix B inverse 0, 1 by 2, -1, 1 by 2, and A inverse 1/5, 1 upon 10, -2 by 5, 3 divided by 10. All right, my students. First row multiplied with first column, 0 -2 by 10. It is equal to -1 by 5, right? -1 by 5. In this one, 0 plus 3 by 20. Direct I write 3 by 20. Next. This one will be -1/5. Multiply these two students, 2 cancel, -1/5. So it will be equal to -2 by 5. 5 LCM, -1, -1, -2 by 5. And these two students, -1 upon 10 and plus 3 by 20, 20 LCM, -2 plus 3, 1 by 20. This is your result, students. So from 1 and 2, it is clear 1 and 2 implies that AB whole inverse equal to B inverse A inverse. This is a property. You can't say, sir, why? Why is it so? Why we open it in reverse? It is property. If you don't reverse the order, make B first, then it will not be equal. You may verify the result. Let's try to verify it. Just multiply B inverse, A inverse, A inverse, B inverse. You will get a different result. A inverse is 1/5, 1 by 10, -2 by 5, 3 by 10. Students, B inverse 0, 1 by 2, -1, 1 by 2. Multiply them 0, it becomes -1 by 10. Clearly not equal. Clearly not equal. Multiply them, students, 1 by 10. 1 by 10 plus 1 by 20, multiply them 0 -3 by 10. Students, multiply them, I think -1/5 plus 3 divided by 20. You end up with this result. This is 20. This is students 20 LCM, 3 by 20, I think. 3 by 20. Students, this will be 20 LCM, -4 plus 3, -1 by 20, -1 by 20. It is not equal to AB whole inverse. I hope it is clear to you. This was this property. I think it is clear now. By chance, the transpose and inverse, they have the same properties. Just the difference is that inverse is always for square matrices, transpose is for both rectangular matrices and square matrices. Students, what is meant by transpose? A matrix obtained by interchanging rows with the corresponding columns. When you interchange rows with the corresponding columns, it is called transpose. My students, this is for example matrix A, 4, 1, 9, 2, 3, -5. Students, transpose means interchange all the rows with the corresponding columns. First row will be converted to first column and second row will be converted to second column. That's it. It is called AB. It is called transpose. The property is that if you take transpose of A transpose, you will again in A. For example, its transpose is this. Its transpose is this. Now its transpose is again the same result. If you take transpose of something, then again take transpose, you get the same position again. A transpose is equal to 4, 2, 1, 3, 9 minus 5. This is A transpose. Let's once take transpose of both sides. First row will be converted to first column, second row to second column, third row with third column. It is again equal to matrix A, 4, 1, 9, 2, 3 minus 5. Clear? And this is the last property for this lecture. Again, the same property. You will have to reverse the order for A, B whole transpose. Students, for example, this we have this matrix. Students, 2, 1, 3, 4, 0, minus 1. It has 3 columns. Matrix B must have, students, matrix B must have 3 rows. For example, students, 4, 1, 1. Just to have simple results. First, you find students AB. 2, 1, 3, 4, 0, minus 1, B. 3, 5, 1, 4, minus 1, 1. Multiply them, my sweet students. First row, first column, 6 plus 5 plus 3, 6 plus 5 plus 3. And then second row, second column, 8 minus 1 plus 3, 8 minus 1 plus 3. Second row, first column, 12 plus 0 minus 1, 12 plus 0 minus 1. These two, 14, 14 minus 0 minus 1. So students, it is equal to 14 and 10. This is 11, this is 13, this is AB. Now students, if you take transpose of this, means interchange rows with columns, first row first column and second row second column. This is your left hand side. Now students, this is A transpose will be first row converted to first column, second row into second column. This is B transpose, 3, 4, 5 minus 1, 1, 1. Right, students? Okay. Now, B transpose, A transpose. 3, 5, 1, 4 minus 1, 1. Students, multiply first row with first column. 6 plus 5 plus 3, 6 plus 5 plus 3. Second row with 12 plus 0 minus 1, 12 plus 0 minus 1. Second row, first column, 8 minus 1 plus 3, 8 minus 1 plus 3. Last one, 14. 14 minus 0 minus 1, students, it is 11, 14, 11, 10, 13. From 1 and 2, it is clear that they are equal. From 1 and 2, we have this result that AB whole transpose is equal to B transpose A transpose. If you don't reverse the order, they will not be equal. You will have a different result. I can remove this. For example, I mean A transpose and B transpose will give you a different. A transpose here is 2, 4, 1, 0, 3 minus 1. Now you can't say, I mentioned a little earlier that you can't say why is it. So it is property. Like we say when electron is at rest, it doesn't produce any magnetic effect. But once a charge is in motion, it creates magnetic field as well. So it's property. Why does negative charge attract positive charge? Why? It is property that unlike charges attract each other and electron attracts proton and electron repels electron, because it is property that like charges repel and unlike charges attract. So it is also a property that if you don't reverse the order, it will not be equal. A B whole transpose will not be equal to A transpose B transpose. You can see this is B transpose, students. 3, 5, 1, 4 minus 1, 1. I hope you know the multiplication. It will give you 3 by 3 matrix. I have discussed this in detail. Multiplication, it is 3 by 2 matrix, it is 2 by 3 matrix. This is the condition, 3 by 3 will be the result, but it's okay. I write directly 6 plus 16, it is 19. First row, second column, 10 minus 4, 26. This one, 2 plus 4, 6. Now, second row, first column, 3 plus 0 is 3. 5 minus 0 is 5. 1 1 plus 0 is 1. 9 minus 4 is 5. 15 plus 1 is 16. 3 minus 1 is 2. And it is clearly not equal to AB whole transpose. So I think it's enough in this lecture. In the next lecture, we will discuss how to solve a system of linear equations, simultaneous linear equations with the help of matrices. Remember me in your prayers. Inshallah, God willing, we will meet in the next lecture. Do remember me in your prayers. God bless you.